Hello, I'm Brian Young, and today we're going to be doing Module 26103, Introduction to Electrical Circuits. Let's get started. 26103, Introduction to Electrical Circuits. After successfully completing this module, you'll be able to describe atomic structure as it relates to electricity, use equations to determine circuit values, and read simple schematic diagrams. It says all kinds of instruments use electrical circuitry to work. This module explains basic atomic theory and electrical theory. These are the ideas behind electricity in every setting. You'll also learn about electrical units of measurement. You'll understand how Ohm's law and the power equation can be used to find unknown values. So 1.0.0 atomic structure and electricity. It says we're going to identify the parts of an atom, compare the atomic structure of conductors and insulators, and identify the role of magnetism in electrical devices. Electricity is a form of energy that powers electrical devices to do work. Electrical devices include motors, lights, heaters, and many others. Electricity is also used to control devices that are not electrical. For example, a gas-powered car engine runs on gasoline, but you wouldn't be able to start the car or turn it on without the electrical system and a battery. So the starter is electrically operated with the battery, and the spark plugs use the electrical source of the battery initially, and then the alternator takes over and feeds those spark plugs in order to make the engine run. But you need the electricity of the battery in order to start the car. So 1.1.0, examining the components of an atom. You've probably heard this before, that atoms are made up of protons, electrons, and neutrons. Protons have a positive charge. Electrons have a negative charge. Neutrons have no charge at all. So you'll find the protons and the neutrons in the nucleus of the atom, and then the electrons will circle around in an orbit called a shell. The valence shell is the outermost shell of an atom. That's a highlight. So the outermost shell of an atom, known as the valence shell, the electrons in this shell are called valence electrons. The number of electrons in the valence shell determine whether or not the atom will easily gain or lose electrons. So it says, remember the following: the fewer electrons in the valence shell, the more likely it is that the atom will lose electrons. The more electrons in the valence shell, the more likely it is that the atom will gain electrons. And here's an example. Let me see if I can scroll out a little bit there. So here's the nucleus of the atom. They didn't show all of the protons, they just showed the nucleus. But in the first shell, we have 2 electrons, and in the second shell, we have 8 electrons. And in the third shell, we could have as many as 18 electrons, but this element only has 1 valence electron, so it would make a good conductor. If you only have 1 valence electron, there's a very weak electrostatic bond to the nucleus, and it's easy to knock that electron loose. If you have 7 or 8 electrons in the valence shell, it's difficult to knock those valence electrons loose. It's a good insulator. 1.1.2 ions. Let me come back in a little so we can see the words. It says, now let's see what happens when we bring the sodium atom in contact with a fluorine atom. So here's a sodium atom, and it has 11 electrons, and the fluorine atom has 9 electrons. But the fluorine atom has 7 electrons in its valence shell, and it would like to have 8 electrons in order to be happy. So it borrows one of the electrons from the sodium atom, and it becomes a negatively charged ion. The sodium atom becomes a positively charged ion because it gave up one of its electrons. Now it has more protons than electrons. The 2 of them are attracted to each other because the fluorine is negatively charged and the sodium is positively charged. This is how you can make table salt with sodium and chloride, chlorine. You can make sodium chloride. So it says in figure 3, the sodium atom has lost an electron and become a positive ion. It's positive because it now has more protons than electrons. The fluorine atom has gained an electron and became a negative ion. It's negative because it now has more electrons than protons. Ions of the same charge repel one another, while ions of different charges attract one another. So the sodium and the fluorine are attracted together and they'll hang out. They'll live as sodium fluoride. 1.2.0 atomic structures of conductors and insulators. I said before that if you have 1, 2, or 3 valence electrons, you have a good conductor. Those electrons have a weak electrostatic charge with the nucleus, a bond, and it's easy to break those electrons loose. So a conductor is a material through which it is relatively easy to maintain electric current. A conductor must be able to transfer electrons freely, so it has few valence electrons. An insulator must prevent the flow of electrons, so it has more valence electrons. A material through which it's difficult to conduct an electrical current, that's an insulator. And if it has 4 valence electrons, it's neither a good conductor nor a good insulator. It's what we call a semiconductor. And semiconductors are used in all of your electronics, your cell phones, your TVs, your computers, your tablets, whatever. They use that semiconductor material, either silicon or germanium. Uh, Silicon is used more often, and it has a high resistance to heat. But you can dope those materials and make them act like conductors or insulators with just a relatively small change in the material. So here it says conductors. A conductor has 3 or fewer valence electrons. Conductors easily allow the electron flow. Copper and aluminum are good examples of conductors. Semiconductors, again, a semiconductor has 4 valence electrons. They're not good conductors, but they cannot be used as insulators either. Their electrical qualities are in between those of conductors and those of insulators. So that's why they call them semiconductors. Germanium and silicon are 2 examples of semiconductors. An insulator has 5 or more valence electrons. Insulators do not conduct electricity well. Insulators are used to prevent the flow of electricity, and examples of insulators are porcelain and plastic. 1.3.0 magnetism and electrical devices. So this is showing a horseshoe magnet on a piece of paper with iron filings sprinkled on the paper, and you can see how they're lying in these radial bands of magnetism all around this horseshoe magnet. Electricity also produces magnetism. Current flowing through a conductor generates a weak magnetic field around a conductor. If the conductor is coiled around an iron bar, the result is multiplied, creating a strong electromagnet. So if you take a straight wire that has current flowing through it, it has a very weak magnetic field. If you take that wire and you wrap it into a coil, you strengthen the magnetic field. If you then put an iron core in the middle of that electromagnet, you increase the permeability of that magnet. You make it stronger. Uh, it becomes a very good electromagnet when you do that. 1.0.0 section review. It says a proton repels another proton. An atom with 7 valence electrons is most likely an insulator. If it has 5 or more, it's an insulator. Current flowing through a conductor coiled around an iron bar produces an electromagnet. See, very good. We'll move on to the next section.